Clearly this is a question about a binomial expansion, so you may want to revise from Blue Book 2 Chapter 4, and you probably also want to remind yourself of the formula that's given in the formula book. And because we're only asked for the first 3 terms, then I've copied enough of the formula book for us to get on with this question. Another important point to remember is that the formula must begin with a bracket containing 1 plus x. So where we've got 4 plus x, we're going to have to deal with a factor there to simplify that. So we'll start by rewriting the given function in index notation. So 1 over a square root means we've got 4 plus x to the negative a half. And as we just said, we need to take that 4 outside as a factor. And of course, there's 2 things to be careful of there. When the 4 comes out, it has the power of negative a half attached. So we've got 4 to the negative a half. And inside the brackets, when we take 4 out, we're left with 1 plus x over 4. So when we're using the binomial expansion, where it refers to x, we'll actually be writing x over 4, and we'll be writing it in brackets again for when it gets squared. We need to be careful with that. Okay, let's go. So 4 to the negative 1/2 is 1 over the square root of 4, so that's 1 over 2. And some big brackets. First term of the binomial expansion is 1. Second term is nx. N is the power, that's negative a half. And x in the formula is our x over 4. So that's the first term done. Next term, we've got n, which is negative a half, multiplied by n minus 1, which is negative 3 over 2, multiplied by x squared, which is x over 4 in brackets, all squared, and all of that divided by 2, so I'm going to write an extra factor of a half on the end. And in theory, there would be many, many, many more terms after that to write. Now we need to simplify all of this, so let's keep the half outside a little bit longer. We've got 1. Second term is negative, and it's negative x over 2 times 4 is 8. Next term, 2 negatives multiplied to make a positive. It's a positive term. It'll be an x squared term. We've got a 3 on the top, so we've got 3x squared on the top. And we've got 2 multiplied by 2 multiplied by 4 squared, 16, multiplied by another 2. That gives us 128 as a denominator there. And we don't need to write any more of the terms. Finally, we can expand that. So we've got 1/2 minus x over 16 plus 3x squared over 256. And that's the first part of the question completed. Just before we move on to part B, let's actually summarise a little bit more carefully what we've achieved here. So the idea is the function on the left, the function we were given, is roughly the same as the quadratic that we've got on the right. And this approximation is valid as long as x is small, and in this case, we need the modulus of x to be smaller than 4. So now let's take a look at part B of this question. First thing that stands out is the word hence. It's not even hence or otherwise, literally hence. Using what we've just done, find the first 3 terms of the binomial expansion of 1 over square root of 4 minus x cubed. So the only change is the original plus x has become negative x cubed. So we're going to do the substitution, or the replacement if you like, of the x in our original expansion being replaced with negative x cubed. So we're going to go through our quadratic expansion and replace each x with negative x cubed. The first term is just a half, and that's independent of x, so it just stays as 1/2. Negative x over 16. Negative x is going to become negative x cubed over 16 plus 3x squared, well, x is now negative x cubed, so negative x cubed squared over 256, and we can simplify these terms a little bit further before we finish. We're going to get 1/2 again. Next term is going to be positive x to the power 3 over 16. And the final term is a negative squared, so it's going to be positive. The power of x is now going to be 6, so it's going to be positive 3x to the 6 over 256. And we are finished. The following part of the question actually uses this same function, so let's just tidy up again what we found so far. We've got an approximation, so the function we're approximating is 1 over the square root of 4 minus x cubed, and we found that that is approximately equal to this polynomial. So now let's take a look at part C. Okay, so now we're asked to find an approximate value for an integral, and the function that we would try to integrate is the one that we've just approximated in part B. So we can rewrite the given integral with this approximate version. It's approximately equal to the integral from 0 to 1 of a half plus x cubed over 16 plus 3x to the 6 over 256. So we just need to integrate each of those terms, substitute the 0 and 1, and get a 7 decimal place value to finish. It's always worth reading the accuracy that they want, 7 decimal places. Writing in the rest of these terms, we've got x over 2 plus x to the power 4 over 64 plus 3x to the power 7 over 7 multiplied by 256. And we've got to evaluate this between 0 and 1. When we substitute 0, it will be 0, that's worth checking. So we just need to substitute 1 in here and get our final value. So we have 0.517291. What you could try on your calculator is actually entering that integral as it's given, square root of 4 minus x cubed, and we should get a very similar but not exactly the same value. The next part, it's only 2 marks, but it's picking up on quite a subtle point. It's asking what would happen if we increased the number of terms that we used in this integral. And the thing to notice here is that all of the terms in this binomial series that we've used, and where that came from, they are all positive terms. So every time we use more of them, the total value of our integral will increase a tiny, tiny bit, but it will keep increasing ever so slightly up towards what the true value should be. Okay, so if the approximation is increasing towards the true value, that means that our approximation will always be an underestimate. Okay, if all the terms were negative, we'd be decreasing down, so we'd have some overestimates. If the signs were alternating, then it's impossible to tell. Okay, but because all the terms in our series are positive, we have an underestimate for the true value of the integral. So there's just one final part of this question left for us to look at, which is D part 2, and actually I don't think that uses the expansion. Let's have a look. So this is asking us why a particular approximation would be invalid, and there are 2 ways that we can actually explain this. First of all, let's think through the binomial expansion we had. The original function, when we expanded it, was valid for the modulus of x being less than 4. Then x essentially got replaced by x cubed. It was minus x cubed, but in modular signs that means we now need the modulus of x cubed to be smaller than 4. And the cube root of 4 is not much bigger than 1. The cube root of 4 is about 1.58 or 1.59. So we can't use this approximation for an integral that starts at -2. -2 is outside of this range of valid x values. So the approximation we're using is not valid at x equals -2, so Edward can't use it to evaluate his integral.